Hello everybody, welcome to part 10 of Senior Developer in 24 Hours. My name is Andres and today we'll be talking about high quality unit testing. Alright, so what is the main takeaway of this video? The idea is that after this video you'll be able to understand the importance of having good unit tests. We are also going to review some of the basic principles of unit test, and we're going to explore what makes a good unit test. Okay, so the first thing is, why are unit tests important in the first place? Uh, the most obvious thing is that they help us to catch bugs earlier on in the development process. So we're shifting left the detection of bugs, and the sooner we detect that we have a bug, the cheaper, the easier it is to fix that bug. It is also going to help us improve maintainability of the source code. Why? Because when we have a unit test and we're making changes, we have a lot better handle whether the changes that we're making are going to have unintended consequences. It is also going to increase the confidence in the code base. It is going to increase the confidence of, users, of other developers that might use our code base. It will even increase the confidence that we have ourselves in the code base. And it will make it easier and faster for us to make changes. It is also important to note that unit tests can show the presence of bugs, but they cannot show the absence of bugs. What that means is that if we have unit tests that are failing, we can be fairly certain that there is a bug, especially when we have tests that used to work and they no longer work. However, just because we have all of our tests passing, all of our tests are green, it doesn't mean that we have no bugs in the code. However, there's still a very useful tool to be able to detect when we do have a bug. All right, other things. Unit tests should be deterministic. It doesn't matter how many times you run it, you should always get the same results. A good unit test is going to break when you make a significant change to the code. If we have unit tests that are not going to respond to changes in the code, then probably we're not writing them in the proper way. Unit tests are also going to show us if maybe we have to refactor some of the code. Because, at least in my experience, if the code is hard to test, we should think about refactoring. Unit tests should also be easy to understand. They should be easy to follow. This is going to help a lot when we have new developers that we're onboarding, things like that. Whenever we have somebody doing maintenance and they need to go in and out, make one quick change, having unit tests that are easy to understand are going to help those developers that might not be as familiar with the code base to understand what we are doing. All right, so we talked a little bit about the basics of unit test, but what is a unit? The concept of a unit depends on the language that we're using, and it's normally defined as the smallest portion of code that can be isolated and tested independently. So, if we have a procedural or functional language, it is fairly easy to define. It is basically a function or a method. When we're talking about object-oriented languages, it can be a little bit trickier to define what is the unit, what is that smallest unit of code that we can test independently. Maybe it is a class. After all, it is an object-oriented language. A class should be able to stand on its own. But in some cases, it could be a function or a method, especially when we have things like utility classes and things like that that have maybe hodgepodge of different functionality. Maybe the smallest unit that we can test in that case is going to be a function or a method independently of the whole class. All right, how do we organize our tests? And the easiest way to organize a single test is follow the arrange, act, assert paradigm. This is also known as given, when, then. And it's basically, just breaking up each unit test into three easy to understand sections. The first one is arrange. Here's where we start all of our tests by creating a known state. For example, we'll create the system under test. That smallest unit of code that we're going to test, we're going to set it up here. We're going to create it if it is an object. We're also going to create all of the dependencies for the system under test. And we're going to wire any dependencies. In this section, what we're basically trying to ensure is that everything is in a well-known state. And you might also see the term fixtures because, it is a fixed state from which we're starting. And, this dates back to testing production lines and things like that, where they had fixtures to ensure that things were being produced according to the spec. All right, the second section is act. When we are actually executing the behavior that we're going to test. And in here, it is important to keep the action focused on the system under test. Normally, it is a single call to a method in the system under test, but it is important to, have it as a separate section to make it clear to anybody that's going to be doing maintenance, what is it that we're really testing about this particular system under test. Then finally, third section is assert. We want to assert that we actually got the expected outcomes. Here we can check return values. We can also check, for example, if our mock objects have been invoked, things like that. All right, how does it all look together? A very simple example would look something like this. In the first line, we have the arrange, where we're setting up our system under test. In this case, is an object created from a class called basic. Second section, we are acting upon it. We're calling a method in our system under test. And in the last section, we are asserting that we got the right value. Of course, you can have multiple lines, especially in the first and the last section. We could have multiple dependencies that we need, and we could have multiple assertions to verify that our call was successful and that we got the expected outcome. With that said, why is this paradigm important? First thing, makes it easier for other developers to understand the test. It is very easy to follow. You understand what is being set up, you understand what we're calling, and then we can easily understand what we're checking against. Makes it easier to debug the test because you can see exactly what code is being executed and what code is relevant for the test. Okay, in general, what are some best practices when we're writing unit tests? And, very generic best practices. We want to keep our test simple and focused. Ideally, a test will not have any branching. It will not have any conditionals. Sometimes this might be a little bit tricky, and in a little bit, we're going to talk about some techniques to be able to handle more complicated cases. But the simpler the test, the easier it is going to be for a developer to understand what is going on, and the easier for them to, make any changes. And the most important part, the harder it is for a developer in the future to go in and hey, I don't understand this code. I don't understand this test. I'm just going to remove it because it is not passing and I don't understand what it's trying to do. So, if it's very evident what you're trying to do, it is a lot easier that that test will be useful in the future and that it will also be kept, that it will also be, maintained in the future. Unit tests should be able to run fast. Developers should be able to get very quick feedback on the changes that they're making. And we also want to leverage our framework to have better tests. And finally, use test doubles and mocks to simulate anything external that the system under test depends on. Something else that is important, we want to extract away anything that is non-deterministic. We were talking about how unit tests should be deterministic. Whenever we run a test, we should always get the same result as long as the inputs and the code remains the same. To do this, we want to, again, extract away anything that we could consider to be non-deterministic. In particular, external systems, if we're talking to databases where we don't have full control, databases that we might be sharing with other developers, things like that, those things could be non-deterministic because a developer might come in, they might make some changes while we're running our test, or, maybe this other developer is running their own tests. All of those things could affect us. So we want to extract away those external systems. But there are other things, right inside of our code that could be not deterministic. And they are, fairly simple, fairly basic operations, but it's good to be aware of them. For example, getting the current time. Depends on how we're using the current time. That could have an effect on our tests that could make them not deterministic. Another important one is random number generators. If we have an algorithm that requires a random seed to be able to, do encryption, things like that, a random number generator might make the test harder to write, might make it non-deterministic, things like that. So maybe it is a good idea to extract things like this. And we're going to go into a lot more detail on how we can extract those things. But for now, just keep in mind, if it is something that is non-deterministic, it can be a problem for our test, and it can result in flaky tests, which is never good. It's never a good experience for the developer. Something else that it is very important, never mock the system under test. This might seem obvious, but if you're mocking parts of the system under test, you're basically defeating the purpose of the test. We want to avoid what is called a partial mock. Partial mock is when you're mocking only part of the system under test. And sometimes it might make it easier for us to write our tests, but it can complicate understanding what the test is doing. And, remember, what is our definition of the unit? Are we testing this unit? Is it really something that we can test independently of other components? So, if it's not something that we can test independent of other components, maybe we are not using the best design patterns to create this unit. All right, but in practice, can't I mock some of the methods in my class to make it easier for my test? Well, you can, but normally you shouldn't. And, the practice of mocking some of these methods is called partial mock. And in a lot of cases, it is normally a code smell. Now, obviously, for every rule, there are some exceptions. And there are legitimate cases where partial mocks might make sense. For example, when we're mocking third-party interfaces that we don't have full control over, things like that. Also, another big one is when we are testing code that we're in the process of refactoring. Sometimes, we inherit code that is legacy, doesn't have the best practices, doesn't have all of the testing that we want. Maybe it doesn't have any testing at all. So what do we want to do? We want to start writing some tests, start building up that test library so that we can make changes with more confidence. And to be able to start building that test library, sometimes we have to do, take some shortcuts. One of those shortcuts might be creating some partial mocks of this big piece of code, this big class that we're trying to refactor. And we're also trying to build tests as we are refactoring. All right, some more best practices. Obviously, try to maintain a high test coverage. Use a tool to measure coverage. And every language has, well, pretty much every language has tools to measure coverage of your unit test. If you're using Java, you can use something like Jacoco. If you're using JavaScript, TypeScript, Istanbul is a popular choice. If you're using Python, there's coverage.py. So, there are a lot of tools. And this is important because something might change, they might make a change in the CI/CD pipeline, they might make a change in one of your build files, and maybe suddenly, some of your tests are not running. So if you're not measuring coverage, it is possible for a test to no longer be executed and for it to be completely silently ignored. So coverage is going to give you, again, a good measure of how much code we're actually testing, and also a good measure that the tests are actually running and they are executing the code that you think they should be executing. Now, talking about this, we also want to make it very easy to run our unit tests. Ideally, you should be able to run all of your unit tests by running a single command. You want to configure your automated build to be able to run your test in a single command. This is probably the same command that you're going to use from your CI/CD server, from your CI/CD pipeline to execute your test. So, make it in a way that you can easily run it from your developer workstation, from your developer laptop, as well as making it easier to run from the CI/CD pipeline. And one of the things is that if running your unit test requires a lot of setup, a lot of things, maybe you're overcomplicating your test. Maybe you should think about extracting some of the external services, things like that. In the same way, debugging your unit test should be simple. Unit tests, at the end of the day, they're just code. Pretty much in all of the cases, they are tests that are written in the same language as your actual code. So unit tests should be runnable from your IDE, just like if you were running any other piece of code. And again, not only should the test be easy to run, but it should be easy to run all of the tests at once or piecemeal so that the developer, when they're debugging the test, they have full control. And again, we're trying to optimize the time of your developers. We're trying to make sure that we're not wasting their time. So we want to give them full control over what they're doing. Because at the end of the day, sometimes you're going to run into this case. You're going to run into flaky unit tests. Basically, a flaky unit test is one that works, doesn't work, despite zero changes to the code or to the test. There's something that is not deterministic. You're going to have to debug this. You're going to have to run it multiple times. You want to make it as easy as possible to be able to run this. Why do we get flaky unit tests? Well, plenty of reasons. When we have things like, multi-threaded code that is not properly isolated, that is a very common case. When we have unit test code that is not properly isolated and you have the test running in multiple threads, things like that. So, for example, when we have some kind of shared resources between the test and the tests are not always running in the same order. Also, when we have reliance on external and maybe somewhat unreliable, maybe somewhat non-deterministic resources. We were talking about that. Hey, external resources like databases, external web services, things like that. And also, random number generator and the system clock. Those are all external resources that might change. And, I've seen tests that start failing whenever we switch from one year to another year. Why? Because the test was expecting that we were going to get, the year 2023. And suddenly when it's 2024, the test is no longer passing. So this is an example of a flaky test. It used to work, now it doesn't work. We didn't change anything in the code, we didn't change anything in the test, but something external changed. And, something else that could happen is resource exhaustion. When we're using too much memory, when we're using too much CPU, things like that, we could end up with unit tests that randomly fail. And finally, something that sometimes happens is hardware issues. You know, sometimes there's uh, things that might not be super evident, but they cause slightly erroneous computations every so often, and that could result in unit tests. And because of all of these complications, flaky tests must be fixed as soon as possible. Because, they erode confidence in your test suite. They're going to erode confidence in your CI/CD pipeline. They're normally an indication of an underlying issue that we should be fixing. All right. Now let's talk a little bit about some of the different types of testing that we have. And most different testing strategies can be considered either white box or black box testing. So let's take a look at black box testing. When we're talking about black box testing, we're only considering the external behavior of the system. When we're writing this kind of tests, we don't need to have any knowledge of the implementation. We only care about what goes in the system and what is the behavior of that system. And these kinds of tests, they can be written by testers, by the QA team. They can also be written by business analysts, the people that help define the requirements, things like that. But us, as developers, can also help them automate this black box testing. And we're going to talk a little bit more about that in a future section. Okay, now let's go ahead and talk about white box testing, which is the counterpart to black box testing. So when we're doing white box testing, we are taking into consideration the internal functioning of the code. We care about the internal state, we care about the values of intermediate variables that we use inside of our code. Pretty much all of the unit tests that we write and some very granular integration tests can be considered white box testing because we have a lot of awareness, a lot of knowledge about how the internals of the code work. This is the most typical unit test that we write, where we write some functional code and then we write the corresponding test, basically, matching one-to-one with the code that we wrote. And because of this is normally done by developers. Now, with that said, let's take a look at a couple of black box testing approaches. We're going to take a look at functional and boundary testing. Okay, so let's start with functional testing. And again, keep in mind, we're talking about black box testing in this particular context. And the focus here is on the business requirements of an application. Here, we are really only concerned about the output of the system. We're not very concerned about the intermediate state of the system. As long as the output is correct, then our functional testing would be passing. These are the type of tests that you can discuss with the business analyst. When you're clarifying business rules, when you're clarifying maybe examples that they're giving you, those things, you should be speaking pretty much the same language as the business analyst or whomever is giving you the requirements. Functional testing can be implemented with the technique that is called behavior-driven development. And, there's plenty of tools in the ecosystem. For example, there's Cucumber, which is a tool that is available in multiple languages. There's JBehave, which is a Java-specific tool. And the nice thing about this behavior-driven development tools is that they allows us to write tests in a very straightforward language, a language that it is very easy to use to communicate with business analysts, or with the people that might not be very technical, the people that might not be able to understand code. So in here, for example, we can describe scenario where we're testing an account calculator. We have one particular scenario when we start an account with 10, the user withdraws 10, the transaction is approved, the new balance is 10. So, well, one thing that becomes evident here, going back to some of the first things we were talking about, we're basically implementing the given, when, then paradigm. So, we're following the same setup, execution, and then we're checking out our assertions, but we're using more natural language. One of the nicer things is that some of the frameworks will even help us to create the boilerplate code that allows us to execute those scenarios that have been written in, basically English or whatever language you want to use. So for example, if we run the previous feature with Cucumber, we're going to get the method signatures of the steps we need to implement. So for example, we would get some output that says, hey, to implement the steps, you want to use the snippet below. We get the signatures, we get the annotations, and then it is up to us to write the Java code or whatever language we're using to create the glue logic between the behavior-driven scenarios and the actual code that we're going to test with this setup. All right, now let's talk about boundary testing. The idea of boundary testing is to focus for checking for errors at the boundaries or extreme ends of a given input domain. The truth is that for many systems, we cannot really test every case. So with boundary testing, we can select meaningful test cases to cover the different ways in which our code can work. So, how do we do boundary testing? And again, this is basically just a technique to come up with the kind of testing that we should implement in our particular unit test. The first thing is, we want to determine the valid input range of a particular method. Then we want to partition the different inputs that we can get, what is valid, what is invalid, what is below certain thresholds or above certain thresholds, things like that. And based on this, we can select cases at the junction of the partitions. Basically, for example, if we have a function that will go from valid to invalid, then we want to test the values that are at that particular junction. And then we evaluate the results from these cases. So basically, we want to test an almost valid value. We want to test a barely valid value. And then, depending on the type of testing that we're doing, the type of functionality that we're testing, we want to also test a few values that are in the middle. All right, so to wrap things up, we've talked a lot about why writing high quality unit tests is really important for our development process. And, basic stuff. They help us uncover bugs. They make maintenance easier. It makes it easier for us to make changes. It makes it easier for us to make changes without causing, side effects, undesired side effects. It increases the trust in the code base from the developers and from the users, because they know that if we fix a bug, we create a test, then that bug is not going to creep up on us again. And the most important part is that it makes developers more effective. If we have simple but comprehensive unit tests, our developers are going to be able to move faster. They're going to be able to move with more confidence, make changes in a more, trustful way. So, that's the key benefit that we get spending the time to write unit tests, because sometimes writing unit tests can be more complicated than writing the code itself. But if we get into that habit, we are going to increase the effectiveness of our team, and also we're going to increase the morale because we're going to spend less time fixing a bug or chasing bugs and things like that. With that said, there's still a lot to talk about in terms of testing, unit testing in particular. So in the next video, we're going to talk about some more advanced unit testing techniques. We're going to talk about how we can create cleaner tests using parameterized tests. We're also going to talk about what is hard to test code, how can we identify it, and what are some of the techniques that we can use to test this complicated code. All right, everybody, thank you for watching. If you enjoyed this video, please feel free to share it with your peers, with your networks. You can follow me on Twitter, you can follow me on Mastodon, or you can check out my webpage, www.javaprocess.com. Thank you. See you next time.